Now, on top of that, we also have our provisioning maintenance. And over in the provisioning, as we kick off our scheduled tasks, and I'm going to go here to Tools and Provisioning, I'm going to drop down into the OS Provisioning. And in here, what we have is we have our provisioning templates. And when I refresh this, you'll notice here that right now I only have one history template. This history template is denoted by this yes in the locked column. Anytime we take a template and we schedule that template as a scheduled task, it's going to create a history template. And so I took my Firefox template here and I scheduled it, and it created this history template here. Now with the history template, in here underneath the history section, it's going to show me which machines I ran it on and whether or not it ran successfully. Now with these history templates, that's all the value that they have. So there's not a lot of value there. So an administrator, what they're going to do is from time to time, they're going to come in here and they're going to right click and delete these history templates, the templates that are locked templates. Now we do have customers though that they take those history templates and they move those over into a public space. They right click on them, there's an option that says make public, and they move those templates over into a public space. The reason why they're doing that is because the template is locked. No one can make any further changes to that template. They can schedule it, and it will go in and it will carry out the actions that we built into the template, but no one could go in and modify it. And when you create those history, or when you use those history templates to create new tasks, then it does not create any additional history templates. So that will also slow down on the production of history templates when you're going in and you're scheduling a history template or a lock template in your scheduled task. So again, like I said, some organizations, as they're running their testing, they'll come in and they'll schedule a template as a test, and then they will take that history template, they'll right click on it, and they'll indicate that they want to make it public, which then takes that template and moves it over into this public space. Then it will be available to other technicians to be able to use that to schedule and carry out whatever that template is intended to perform there on these managed devices. So again, that is our ability to go in and to maintain that history, or maintain those history templates, is by going in and deleting the history templates that we no longer need. Now it also in here talks about working with our self-electing subnet services. Now this is a really nice technology that Ivanti has that we've also enhanced recently to be able to make it even more efficient in the way it's going to operate. Now if I get here into the agent settings, within these agent settings I'll be able to get in and take a look at my client connectivity settings. In these client connectivity settings is where we can turn on the self-electing subnet services. As you can see here, this has been enabled. And we can also see that these other tools here have also been enabled. These are part of these self-electing subnet services. One of those tools is creating a Pixie representative, or having an agentless inventory scanner, or being able to go in and pick up the agent state. All of these are being driven through the self-electing subnet services. Now what happens here is that the core server for all the different subnets you have, and here we can see a core server with 4 subnets, it's going to take a machine and through an election process, it's going to elect it to carry out a certain role. When that machine goes away, then the core server knows that, it's going to run another election, and it's going to select a different machine to carry out that role. So within our environment, the core server is going to give us the ability to go in and start to drive the automation of some of these processes, like having a Pixie representative actually elected within each subnet, but only one Pixie representative per subnet. And then if that machine happens to go away, person takes their laptop, they take it home, they've gone off to a meeting, machine's no longer there on the subnet to carry out that role. The core server will run another election, and we'll pick a different machine then to carry out that role, as long as it's received that setting that it will then participate in that election. Now I can also get in here and I can take a look at what machines have actually been elected. If I get in here into the self-electing subnet services, this is going to show me which machines have actually been elected. Now in here we can also set the default state for any new subnets that come along. You know, how do we want some of these particular parts of the system to operate here? So I'm just going to let this go in and bring up these services here. But then in here you can see that for new subnets, I have these services enabled. Now it's important that we have the settings, the agent settings that have been deployed out to client machines that will then take effect or that will utilize these self-electing subnet services that are being offered up out there. So if I get in here and I look at my agentless scanner, for my little subnet here that I have my machines, the PS machine here was elected as my agentless scanner. And so again, I can see that. And if I had more subnets, if I had multiple subnets here, then I could see what machines have been elected into those different subnets. And again, they're carrying out that particular role. In this particular case, not only is my PS machine doing the agentless scanner, but it also is doing the PXE services. So it's carrying out multiple roles here in the way that I'm driving this. Again, these services are pretty minimal as far as the resource load on the machine. So it's going to be okay for a machine to actually serve in multiple roles. But with that, again, the beauty of this is that as long as we've maintained our settings correctly and the self-electing subnet services correctly, we're going to have the core server automatically electing devices to carry out those roles. Based on the algorithm that the core server uses, we are probably getting the best machine we could possibly get within that subnet to serve that role. Otherwise, the core server probably would have elected it because it would have found a machine that would have been better to serve in that role by the algorithm that it's using to go in and run that. So again, part of that maintenance of the system is to make sure that the self-electing subnet services is working properly and that we're getting devices elected into these different roles.